Do you ever wake up in the morning with no idea what to wear?
Oh my god, I'm gonna be late for class, and I don't know what to wear.
Have you heard of Style Sprout?
No, what's that?
Style Sprout is an app that generates outfits for you using clothes from your own closet.
Oh my god, that's so cool. I'm gonna use it right now. Perfect, I'm ready for class now.
You look great.
Thanks, Style Sprout.
Do you have so many clothes that you can't keep track?
What should I wear for my Capstone demo? I don't really own anything appropriate. I guess I should just go buy something.
Stop right there. Instead of buying new clothes, you should try Style Sprout. It'll help you keep track of and use all the clothes you already own.
That's so cool and environmentally friendly. Let me generate an outfit right now.
Of course, here you go.
Wow, I look great and totally ready for my Capstone demo now. Our project utilizes computer vision to classify the pieces in your closet. So computer vision is a type of artificial intelligence which allows computers to analyze visual data. So our project has a camera which will take a square image. This image will be fed through 3 different classification models. One for clothing type, which will tell you if the piece of clothing is a t-shirt or jeans or something else. One for color, which will tell you the base color of the clothing, which could be something like red, blue, and then also the usage of the clothing. So whether that piece of clothing is formal or casual. Now, the ideal input image for us is a piece of clothing that is either laid flat, hung, or worn on a plain color or plain pattern background. So like I mentioned before, we have 3 different classification models, each predicting a different type of label. And we're utilizing the ResNet 50 architecture for our machine learning models. And this architecture is widely used in machine learning for image classification tasks. And it's made up of different layers that have groups of interconnected neurons, which are basically a bunch of different numbers that are going to help process visual data, which is our images. And these neurons will learn how to identify certain patterns, which could be things like the edges of an item, the general shape of an item, or the color of the item. And each of these layers, again, as I mentioned, has weights, which are numerical values that will adjust the influence of certain inputs on the output. So if you look at an input image, it's really just a group of pixels. We can look at this specific group of pixels, which is the collar. So our clothing type classification model would kind of learn to predict that if a piece of clothing has this type of collar, which is really common in blazers, the output type is probably going to be a blazer. So to train our classification models, we had to give them a lot of data. And the data that we gave them was an image with a label. So for example, for our clothing type model, if we gave it this image, we would tell it that this is a blazer. And if we gave it this image, we would tell it that this is lounge pants. For our color model, we would tell it that this is a black piece of clothing, and we would tell it that this one is a green piece of clothing. And for our usage model, we would tell it that this is a formal piece of clothing, and we would say for the usage model that this is a casual piece of clothing. And we had to give our models a lot of data. So for each of our 16 possible predicted clothing types, we had 5,000 examples. For each of our 12 possible colors, we had 500 examples. And then for each of our 2 different usages, we had 2,500 examples.
Now we're going to talk about where this classification is run, which is on an edge computer. An edge computer is just a computing device that is located on the edge of networks. So it's a little bit closer to sensors or other kinds of data that you can get in real time. In this edge device, we're using a Jetson Xavier NX. It's manufactured by NVIDIA, and it's heavily optimized for machine learning uses, which is our use case. And on this edge device, we of course do our classification, but we also do a couple other things, including video taking, and we get some user input from a button. And when we click this button, we're able to take a picture. So if I click it, we can see that it selects a picture to take, and then it'll send that picture to the cloud, and it will send the information about that picture to the backend. And after all that's done, we can use that information that we got from scanning and use it in the app. So now that we've talked about how all the systems function, you might be wondering, how do I actually scan something in? You're going to want to try to center your piece of clothing in the camera. So it's a little bit finicky at times. Just try to take this edge and get it as best as you can so that it gets the entire piece. Now, once you've centered it, you can click the button. It'll take a picture, classify it, and then send it to the backend in the cloud.
With StyleSprout, privacy is our top priority. So when you first open the application, we'll ask for your permission to save images of your clothing, and these images are securely stored and used exclusively to enhance your outfit recommendations. Users can generate outfits by navigating to the Generate Outfit page. Here they can select whether they want a formal or casual outfit, and we'll generate based on that. We use reinforcement learning to understand your style preferences, and by analyzing your choices, our algorithm learns what color preferences you have and outfit combinations you don't like. Every time you select an outfit, our system tracks the color combinations of it. This allows us to curate future outfits that align with the style. And if you're not a fan of an outfit, dislike it. Our algorithm will adjust future recommendations to suggest it less. Additionally, all outfits we generate will be tailored to the formal or casual occasion. To further adjust our app to your needs, we allow users to set their location and wear limit within settings. Outfit generation uses their location to generate for their local weather conditions, and the wear limit is used for our laundry feature. To keep your wardrobe organized, we add one usage to an item when it's in a generated outfit that gets selected. And if the item's usage gets up to the uses before dirty or wear limit values set in settings, the item will be considered dirty and won't be included in future outfit recommendations. But don't worry, because you can simply select the Do Laundry button to update all your clothes as clean again. So for our closet inventory page, you can scroll through all of your clothing items. You can also view and edit the classifications of each clothing item. So for example, if your app mistakenly classifies a shirt as shorts, you can correct it here. You can also manually adjust the number of uses for specific items or delete items you no longer want in your wardrobe. By using our automated classification model, uploading and organizing a wardrobe is 40.62% faster than traditional wardrobe apps where users have to manually upload and classify every item. Behind the scenes, StyleSprout stores all user data in a secure MySQL database. This includes clothing details like the type, color, and cleanliness, preferred color combinations and disliked outfit pairings, and also user-specific settings like location and laundry thresholds. The database ensures everything stays organized, easily accessible, and secure. All of our clothing images are stored securely in an AWS S3 bucket. To ensure privacy, the images are only accessed through our backend under a secure role policy. And the backend retrieves a pre-signed URL for each image, which allows temporary and private access to display images on the app. This approach keeps our data safe while seamlessly integrating image storage into our application. Our backend is powered by FastAPI, which handles all of our database operations and outfit generation requests. For example, when a user requests a casual outfit, the backend runs our outfit generation algorithm using the database tables. It gets the image URLs from AWS S3 and sends the outfit URLs and data to the app to display it. Additionally, when users scan in their clothing, the backend adds the new item along with its data to the database. So our group encountered many challenges during this project. The first challenge that we encountered was finding a good data set. We couldn't find as many images as we would have liked of clothing labeled by color and clothing labeled by usage, so we actually had to end up manually labeling about 5,000 images. We also really encountered some challenges integrating with the hardware. Just downloading the necessary libraries for our project took months, and we had to also convert our trained classification models to smaller versions, which are like a TensorFlow Lite version that are specifically made for edge devices, and this also took a long time to integrate onto our Jetson. And then the last challenge that we really encountered was working with new tools. This was our first time working with computer vision. It was also all of our first times doing mobile app development and using Flutter.